Okay, so in this video, we're actually going to build up from one-step equations and take a look at two-step equations. And just to review a little bit what I mean by one-step equations, let's take a look down here at these four problems. These four problems actually review all of the things that you might see which require only one step to solve. So what do I mean by one step? Well, when you guys look at this equation, we only have a constant that's -5. So the only thing we needed to do to solve this was to do the opposite, which is add 5 to both sides. So if you see a negative constant, you want to add on both sides, which is what you have down here. You see a negative constant, so you added 5. Cool. Now in the next one, when we look at this, we had a positive constant. So when you see a positive constant, you subtract. 10 minus 10 cancels out here, and the -3 minus the 10 gave us the -13. So because we only have one thing with the variable, we only have one step. Earlier, we really practiced how to identify what we're looking at, and I'm actually going to go back to this page right here. You might remember that when we watched the video on this, you had to label that the 2 was the coefficient, the x was the variable, there is no denominator here, and the constant is the -14. So this problem right here, y'all, this actually has two things with the variable. We have a coefficient and a constant. Now over here, there's only a coefficient. So this would have been like a one-step thing. This is going to be a two-step, okay? Every time you see two things with your letter, it could be a coefficient and a constant. It could be a denominator and a constant. But anytime you see two things, you're going to have two steps to solve. Now back over here, we only had one thing with the letter, so there would only be one thing to do for that type of problem. All right? Now I just want to review real quick just the other two problems that you guys had for one step. Notice that with this letter, we only have a denominator, and when you have a denominator, you're supposed to multiply both sides by that denominator. So that was the one thing we had to do to solve this one. And last but not least, over here, we have a coefficient with our variable. So we have to divide both sides by that coefficient. So what all of these have in common is that there's only one thing with the letter. It could be a constant, it could be a denominator, or it could be a coefficient, but they only had one thing, so we only had one step. So now let's take a look at our two-step equation notes, okay? And this should be out in front of you, and you guys are going to take notes and follow along with me. So let's take a look here at this first equation that we have. We have a 2x plus 5 equals 19. So when we drop the line and focus over here, we see we've got a couple things with our variable. We have a number in front of it, which is the coefficient, so I'm going to go ahead and put that there. And we have a number all by itself, the constant, so I'm going to go ahead and put this here. Now before we do anything with the language of algebra, where I show you guys how to take notes, I want you to literally just think about, there's some number out there, we don't know what it is, okay? If you double it and then add 5, you'd be at 19. So again, what we just said was there's some number out there. If we double it, then add 5, we'd be at 19. So what if we did not add the 5? If we didn't add the 5 to get to 19, we'd be at 14. So that means there's some number out there times 2 that gives me 14. And to show it in the language of algebra, we're going to divide both sides by the coefficient. And here we're going to get a 7. Now, if you're just copying and taking notes, that's all good, but I'm getting ready to kind of go back through this problem and explain it one more time. So from the top, we've got a variable with a coefficient and a constant. Anytime you see a constant, you guys know to just do the opposite. So if you see a plus 5, that's the -5 in my work. 5 minus 5 cancels out, and all I have left now is this 2x. So now we're saying 2 times some number would be 19 minus 5, which is 14. Now the 2 is a coefficient, and you guys learned anytime you see a coefficient, you're supposed to divide both sides by that number. 2 divided by 2 is just a 1, and that means we have just what 1x would equal. And over here, 14 divided by 2 is the 7. Now to check, we just want to see if I take that 2 and multiply it by the 7 that we got, which is a 14. Now if we add 5 to that, we do in fact get the 19, so we know we're good to go. So when you're checking this step, you're just using the order of operations, PEMDAS. We multiplied first and then added. So that concludes the first problem, and now we're ready to move over here to the next one. Now again, anytime you see your equal sign, just go ahead and drop your line so you can kind of focus on the side with the variable. Luckily, so far in the video, all of these are going to have the variable on the same side. But as we move on, you guys are going to start to see eventually that I start to move things around. And on the back, we're also, on the next page, we're going to be moving the variable to the other side. So for right now, we're able to focus right here. And again, we've got two parts. I have a coefficient with my x. The coefficient is a 4. And the number all by itself is this 3. So what we're saying up now, y'all, is that if you've got some number times 4 and add 3, you'd be at negative 21. Okay? So we have a constant. The opposite of adding 3 would be to take away 3. This is going to cancel out. And then here you have that 4 times some number equals. Now if you have 21 negatives and 3 more negatives, this is 24 negatives total. And if you need to use a calculator for that part, that's all good. You can actually just type in, I'll show you what it looks like. You've got your 21, that's negative, and then you're going to minus 3, and that's the negative 24. Now this 4, you guys would agree, is called a coefficient. And anytime we have a coefficient, we divide both sides by that number. And if you don't know the negative 24 divided by 4 off the top of your head, that's okay. You'll still have the negative 24 in the calculator, and you can just divide by the 4. And you're going to get the negative 6. So for this one, we get negative 6. Now to check, I'm just going to check up here briefly. We've got the 4, and I'm going to plug in a negative 6. And I'd add 3, and we want to see if we get to negative 21. You could actually use Desmos for that part if you wanted to. It would actually do the order of operations and get the negative 21 that it's supposed to. But here, you guys can see we'd get a negative 24, and then if we add 3, we're getting closer to 0, and that would put us at negative 21, so we're good to go. And now here we have another example, 4x minus 5 equals the negative 13. So again, when you drop your line and you focus over here, you've got 2 things with your letter. So it's going to take 2 steps to solve. Since we have a coefficient of 4 and a constant of negative 5, we're actually now going to add 5 to both sides. See how I'm just doing the opposite of my constant? And the negative and the positive will cancel out, and I can bring down my 4x. Now over here, if you have 13 negatives and then you add 5, you're getting closer to 0. That's going to put us at negative 8. And again, if you need your calculator for that part, all good. Some of you might have thought that that was going to be a negative 18, which means you're still messing up your integers rules. And so it's okay if you need your calculator for that part. And once again, what these all have in common is a constant and a coefficient. So we get rid of the constant first, and now we're ready to divide by whatever the coefficient is. And I do want to point out, if this was a negative 4, it's not, but if it was, then you would just simply divide both sides by a negative. So whatever number you see in front of the x, that's your last step there. You're just going to divide by that number. But since it wasn't negative, I'm going to just undo that part real quick. And our final answer for this one, if we do a negative 8 divided by 4, that's going to be a negative 2. And of course, we got to check, because y'all know I'm a math teacher. We got to check this stuff. So we've got 4 times the negative 2, and then let's take away 5. This gives us negative 8. And if we get 5 more negatives with that, we've got 13 negatives, so we are set. So here's the deal, y'all. Anytime you see a constant and a coefficient, which is what these all have in common, they had a constant, a number all by itself, and a coefficient. What did we do to solve? I'm going to type it in here. We did the opposite. And now you guys know, I'm going to start to put this out there. Another fancy word for opposite is inverse. So we did the opposite or the inverse operation of the constant. Inverse is just a fancy word for opposite. And if we had a positive number, we subtracted. If we had a negative number, we added. So you just did the opposite operation of the constant. And after that, we divided both sides by the coefficient. So those are going to be your steps. Those are the 2 steps. Get rid of the constant, then get rid of the coefficient. You either add or subtract to get rid of the constant, and then you'll divide both sides by the coefficient. Okay? Now, all I'm doing right here is just kind of formalizing the check step from up above. I'm just kind of formalizing the check step. I just wanted to remind you guys that the check step in this unit is really unit 3. When we solved up here and got x equals 7, to check that, you just want to plug it in. You want to simplify this expression when x is 7. So you've got 2x plus 5, you plug in the 7, and when you simplify, we get a 19. And if we go back up here, you see how that's the total we wanted? So that's how you check, y'all. You just use your skills from unit 3. So again, for the second one, when we got that -6, all we're going to do now is plug it in and simplify when x is -6. And when we plug that in and follow order of operations, we get a -21, which is what we wanted right here. So we're good to go. And so for the last one, I already checked it up here, but now you guys can just kind of formalize it in your notes with me. If you were to simplify when x is -2, you would just plug in the -2 and take away 5. So you get a -8 and take away 5, and you would get a -13. So you guys do know how to check every single question in this unit to make sure you're actually getting these things right, okay? All right, now if you want to pause the video and just try these 3 on your own, feel free to pause the video, and I'll just have the work up here for you when you hit play again. And if you want to just see the work, that's okay. I'm just going to explain it I'm just going to explain it right now. But if you want to pause it, just pause it. All right, cool. So I've already got the work here for this first one. So we had a -6. We add 6 to both sides. It cancels out. I've got a 5x would equal 20 over here. Now I divided both sides by my coefficient, and I get an x equals 4. And when you plug it into check, 20 minus the 6 is the 14 that we wanted, so we're good to go. Here, we have a negative constant, so I'm going to add 10 to both sides. All right, we get the 3x equals here. This would be a -6. -16 plus 10 gets closer to 0. We're at -6. Now we're going to divide by the coefficient. And for this one, we'd get a -2. So if you got a -2, you're good to go for that one. And for this one, I'm going to subtract 40 from both sides. We'd get the 8x down here. This cancels out. And over here, this would be 48 negatives. And now when we divide by our coefficient of 8, we get a -6. So the answers to these 3 would have been the 4, -2, and -6. All right, so how is this problem a little bit different down here below? The only reason this is a little bit different is because I've got the constant written first in the expression. But if I were to give you guys this all the way back on the first page of the unit, and I had to ask you guys, like, what's the variable? You would say x. If I said, what's the coefficient? You would tell me this -2. So I'm going to, let me see if it'll let me highlight here. The -2 is my coefficient. X is the variable. And this number all by itself is the constant. So like I said, the downfall in this unit is sometimes you're going to look at a problem and think you're getting confused because it's unfamiliar looking. And then you're going to think, oh no, I don't know what to do. But here, since you guys are really good at identifying now, I think you guys would agree the constant is the 3, and since it's positive, I'm going to take away the 3. That cancels out, and now I've got a -2x. We can't forget the negative. And on this side, 21 minus 3 would be 18. So now you're going to divide by the -2 and divide by the -2. And this time we're going to get a -9. So it's okay if the teacher or the problem switches up the order. It's okay if the constant, which again is the 3, it's okay if that comes first. You know how to identify it. That will still be the first step. It doesn't matter if the constant is right here in the problem or if it's right here in the problem. That is still the first thing you deal with every time. And then the coefficient is the number that's in front of the variable. And sometimes it might be like right here with the variable. But that's the second step. You want to divide both sides by that. And friendly reminder that this school year, when you see the 18 and then that fraction bar, that's the same thing as seeing 18 divided by your -2. So this is a division step right here. And that takes care of our first part of learning how to solve and check a two-step equation. Thank you for watching.